Okay, folks, now that we've had some practice with our radical expressions, simplifying them, multiplying by the conjugate, etc., let's go ahead and simplify find and simplify the difference quotient for f of x equals the square root of x. Let's give this a shot here. So remember that the difference quotient we can think of as the average rate of change, or if you like, it's the slope of the secant line connecting x to x plus h. I encourage you to write that out. It will make you a stronger math student. But let's jump into the definition of the difference quotient here. So it will be f of x plus h minus f of x all over h. What we see here is that the difference quotient hasn't changed just because I've got a different function. And so in this case, the difference quotient would be the square root of x plus h minus the square root of x all over h. And it turns out we can simplify this expression here in that we can eliminate this factor of h somehow in the denominator. And in calculus, the reason why we want to do that will be more apparent. But I want to somehow get rid of this factor of h in the denominator. And my only candidate would be to maybe free up this h that's currently trapped underneath the square root symbol here. So what can we do if we want to free up an h trapped inside of a square root symbol? Well, a clever trick for eliminating radicals in an expression is to multiply, especially if it's a binomial radical expression, is to multiply by that expression's conjugate. So I'm going to multiply this by the square root of x plus h plus the square root of x all over itself. So we're multiplying by this convenient 1 like we've seen a couple of times in our earlier math career. So I want to point out that you've done this multiplication before here, folks. You can see that this expression up here is precisely what I'm asking you to expand out down here. So we'll get a chance to see how that works. And when I multiply this radical times this radical, I'm just left with x plus h. And I'm just going to, out of habit, put that in parentheses, even though in this case there's nothing to distribute through it. My outers would be the square root of x plus h times the square root of x. My inners would be the opposite of that, so my outers and inners add out, and I'll be left with minus the square root of x times the square root of x, which is the square root of x squared, or just x, all over h. And what we see here, folks, is that this cleans up pretty nicely. Oops, I'm sorry, folks, I've made a mistake. In our denominator, we would have this expression here, the square root of x plus h plus the square root of x. And so, cleaning some things up, we end up within our numerator just the factor of h all over the factor of h times the square root of x plus h plus the square root of x. And I could distribute this h through, but that's not going to help me because my goal is to divide out that factor of h. So now we're able to do so. And so we end up with an answer is a simplified difference quotient of 1 over the square root of x plus h plus the square root of x. And that's where we'll park our answer. That was tough. Let's try that again here, folks. We're going to try it again with a slightly more challenging problem in that we've got g of x is equal to the square root of 2 minus 3x. So let's give that a shot here. So again, our difference quotient computes the average rate of change. We'll talk more about this in class, which is equal to the slope of the secant line connecting x to x plus h. Again, we'll talk about more of that in class. But this would be g of x plus h minus g of x all over h. Folks, I know this is a little tricky, but a pet peeve of mine is if I give you a function called g, then that should be the function that shows up in your difference quotient. So these names should always align with one another. Watch out for that. Okay. So this will give me the square root of 2 minus 3 times x plus h minus the square root of 2 minus 3x all over h. Folks, I want to point out that in this case, when I went to evaluate g of x plus h, so there's the input variable x, and everywhere I saw the input variable x, I replaced it with x plus h when computing this g of x plus h here. Okay, so we can do some cleaning up. I can distribute that minus 3 through if I like. I can take a line to do that, so maybe I will. I'll do 2 minus 3x minus 3h minus the square root of 2 minus 3x all over h. And our directions were to find and simplify the difference quotient. So we're going to again try this trick of multiplying by the conjugate of the expression in the numerator. So remember that the conjugate is the opposite sign binomial, and that allows those outers and inners to cancel or to add out the way we've seen them add out in a number of the examples that I had you FOIL out before. Don't forget, folks, that we are multiplying by a convenient one here, so don't forget that we're doing the conjugate of the expression over itself. Okay. So, folks, we're going to go ahead and expand this out. What did I want to say? So we're multiplying by the conjugate. And remember, why are we doing this? Well, our goal is to somehow eliminate this factor of h in the denominator. And the only candidate that might help us divide it out is this factor of h right up here, which is currently trapped inside of a square root. And I think of multiplying by a conjugate as freeing up something that's trapped inside of a square root. Okay, so foiling this out would just give me 2 minus 3x minus 3h. My outers and inners will cancel. And if you don't believe me, this is kind of a messy problem to check me on, but go off to the side and actually FOIL out the product of this binomial and this binomial and see that the outers and inners will cancel. So that's hopefully something that you sort of discovered as we did all of these examples here where I was multiplying by the conjugate, I was multiplying by the conjugate, you multiplied by the conjugate, and hopefully we saw those outers and inners adding out as we FOILed that out. This is going to give me negative 2 minus 3x here, all over h times the square root of 2 minus 3x minus 3h plus the square root of 2 minus 3x. Now I can go ahead and clean up a number of these factors. We've got a 2 minus 2. We've got a minus 3x minus a minus 3x. So we're just left with negative 3h all over h times that conjugate term. 2 minus this minus 3x minus 3h inside that square root plus the square root of 2 minus 3x. And then notice here we can finally at long last divide out those factors of h, and we get as an answer to the problem, and I didn't quite give enough room there, folks, we get as an answer negative 3 all over the square root of 2 minus 3x minus 3h plus the square root of 2 minus 3x. There we go. Okay, folks, what I'd like you to do is I'd now like you to try this problem twice more. In each case, I've got a hyperlinked solution for you, so you may have to pull up an electronic copy of the document to check those, but you can, and there are solutions to check them against, and that's all I've got for you. When we get to class next time, we will do some more practice with this difference quotient. Thank you, and bye-bye.